This is a review of how to solve single-step equations. First, our vocabulary. Inverse operations are two operations that undo each other. For example, we have addition and subtraction. They undo each other. There's also multiplication and division. They undo each other. Our other vocabulary word is equivalent equations. Those are equations with the same solution. The subtraction property of equality. Subtracting the same number from each side of an equation produces an equivalent equation. So for example, if x plus 3 equals 5, then I can subtract 3 from both sides, as shown in red here, and I'll end up with x equals 2. If x plus a equals b, then x plus a minus a equals b minus a, or x equals b minus a, if you're thinking in algebra terms. So our example, if x plus 9 equals negative 3, then we need to figure out what x equals. I like to start by drawing a wall down my equal sign. What I do to one side, I have to make sure I do to the other. So I have plus 9. To undo that, I need to minus 9 from both sides. X plus 9 minus 9 is x. My equal sign stays where it was. Negative 3 minus 9 is negative 12. My answer is x equals negative 12. To check that, I take negative 12 plus 9 and see if that's equal to negative 3. Well, negative 12 plus 9 is negative 3, and that is equal, so it checks out. The addition property of equality says that adding the same number to each side of an equation produces an equivalent equation. So if x minus 3 equals 5, then x minus 3 plus 3 equals 5 plus 3. I just add 3 to both sides, and I end up with x equals 8. In algebra terms, if x minus a equals b, then x minus a plus a equals b plus a, or x equals b plus a. Here's our example. 23 equals y minus 11. I'm going to start with my wall. Y minus 11, to undo a minus, I need to add the opposite operation, the inverse operation. We're going to add 11 to both sides. 23 plus 11 is 34. And now y is by itself, so y is equal to 34. To check that, 23 equals 34 minus 11. Well, 34 minus 11 equals 23, so it checks out. Here are a couple examples. Now, the question is, how do I tell which one I need to do? For number 1, we have x plus 8 equals 19. We're looking at inverse operations here. So I have x plus 8. To undo a plus 8, I need to minus 8. We'll subtract 8 from both sides. We're always looking at the side of the equation that has the variable on it. So x plus 8 minus 8 is just x. 19 minus 8 is 11, so x equals 11. To check that, we take 11 plus 8. Is that equal to 19? Well, yes, it indeed is, so it checks out. All right, our next example. Negative 7 equals y plus 13. I'll draw my little wall. Y plus 13 is the side I'm looking at. To undo a plus, I minus that same number. So I'll subtract 13 from both sides. Negative 7 minus 13 is negative 20. Equals y. That should be my answer. Let's check it. Negative 7 equals negative 20 plus 13. Well, negative 7 equals negative 20 plus 13 is negative 7. And that checks out. Number 3 is n minus 4 equals negative 11. I'll draw my little wall. I have n minus 4. So to undo a minus 4, I add 4 to both sides. So I get n alone on the left. Negative 11 plus 4 is negative 7. To double check that, I take negative 7 minus 4. Does that equal negative 11? Negative 7 minus 4 is negative 11. So it checks out. And 26 equals p minus 61. Draw my wall. P minus 61 is the side I'm looking at. A minus, to undo it, I plus 61. Plus 61 on both sides. And I get 87 equals p. To check that, I take 26 equals 87 minus 61. 26. 87 minus 61 is 26. So it checks out. Now you might be wondering, why do I need to check my work? At this point, checking the work seems a little redundant because you can check it in your head. But it's a really good practice to get into because we are going to be doing more complex equations and you will have to check them on paper to be sure you got the right answer. All right, try these problems on your own. The first problem, we are going to subtract 5 from each side. We'll end up with x equals -7. To check, we have -7 plus 5 equals -2. -2 it is. For number 2, my goodness, I'm sorry. Number 2, we have 12 equals y minus 7. I'll draw my wall. I'm going to add 7 in this case. 12 plus 7 is 19 equals y. To check, we have 12 equals 19 minus 7. 19 minus 7 is 12. Perfect. X plus 6 equals 19. I'm going to subtract 6. So x equals 13. To check, I take 13 plus 6. Does it equal 19? Oh, it sure does. 19 equals 19. For number 4, we're going to draw our wall. We're going to subtract 12 off each side. We will get -17 equals y. To check that, we take -5 equals -17 plus 12. And -5 does indeed equal -5. And for number 5, we're going to add 3 to both sides. So m equals -8. -8 minus 3, is that equal to -11? Well, yes. Yes, it is. That checks out. All right, the division property of equality. Dividing each side of an equation by the same non-zero number produces an equivalent equation. So 3x equals 12. I'm going to divide both sides by 3, and I'll end up with x equals 4. Remember, 3x means 3 times x. So if ax equals b, and a is not equal to 0, then I can divide both sides by a, and x will equal b divided by a. All right, solve -6x equals 48. I'm going to draw my wall again. This is -6 times x, so I'm going to divide both sides by -6, and I'll get x equals -8. So -6 times -8, is that equal to positive 48? Well, it sure is equal, so it checks out. The multiplication property of equality says that multiplying each side of an equation by the same non-zero number produces an equivalent equation. So if x divided by 3 equals 12, then I can multiply both sides by 3 and get x equals 36. In algebra terms, if x divided by a equals b, and a is not 0, then x divided by a times a equals b times a, or just simply x equals a times b, or b times a, whichever way you think of it. Now it's important to note that in the division and multiplication properties, the number with the x cannot be 0. That is simply because we cannot divide by 0. The world will explode. All right, we're going to solve 9 equals w divided by 7. So I'm going to draw my wall. W divided by 7, so I'm going to multiply 7 to both sides. 9 times 7 is 63 equals w. So to check my work, I do 9 equals 63 over 7. 63 over 7 is indeed 9, so it checks out. All right, we are going to solve each of these. So try solving these really quick. To solve these, I'll draw my wall. 2x equals 18. I'm going to divide by 2. So x will equal 9. To check this, I do 2 times 9. Does that equal 18? Well, it sure does equal 18. -60 equals -5a. The -5 is on the same side as the a. That's multiplication. So to undo it, I'm going to divide by -5 on both sides. -60 divided by -5 is positive 12. So a equals 12. To check that, I'll take -60 equals -5 times 12. -60 doesn't change. -5 times 12 is -60, so it checks out. All right, y divided by 2 equals 13. To undo division, I'm going to multiply by 2. So y divided by 2 times 2 is just y. 13 times 2 is 26. My answer is y equals 26. To check it, take 26 divided by 2 equals 13. Well, that does indeed equal 13, so it checks out. And for our last one, negative 8 equals b divided by 8. B divided by 8, so I'm going to multiply both sides by 8. Negative 8 times 8 is negative 64 equals b. So to check this, I take negative 8 equals negative 64 divided by 8. Negative 64 divided by 8 is indeed negative 8, so it checks out. All right, try these problems on your own. You have to show your work and check your answers. 5x equals 45. You're going to divide both sides by 5 to solve. X is equal to 9 in this case. To check it, we take 5 times 9 equals 45. Well, 5 times 9 is 45, so it checks out. Negative 56 equals negative 8y. To solve this, I'm going to divide each side by negative 8. Negative 56 divided by negative 8 is 7. 7 equals y. So to check it, we take negative 56 equals negative 8 times 7. Negative 8 times 7 is indeed negative 56, so it checks out. Number 3, I have 5 equals w over 11, or w divided by 11. So I'm going to multiply both sides by 11. Now we'll get 55 equals w. To check this, I have 5 equals 55 over 11, which is indeed 5, and it checks out. Number 4, m divided by 4 equals 11. I'm going to multiply each side by 4. M is equal to 44. To check this, we take 44 divided by 4. Is that equal to 11? 44 divided by 4 sure is 11. All right, for number 5, negative 9 equals c divided by 6. Draw my little wall, c divided by 6, so I multiply by 6 to solve. Negative 9 times 6 is negative 54 equals c. To check this, I take negative 9 equals negative 54 divided by 6. 54 divided by 6 is indeed 9. My answer works out. And the last one, negative 7x equals 42. I'm going to divide both sides by negative 7 in this case. X is equal to negative 6. So to check my answer, I take negative 7 times negative 6. Does that equal positive 42? Well, 7 times 6 is 42, and a negative times a negative makes a positive, so it worked out. Your assignment is the one-step equations packet. You will get more work time in class.